video, we're going to be looking at vector multiplication dot product, where we'll be discussing scalar product, or the other word that can be used for this is dot product. So this can be defined as a product of magnitude of the two vectors and the cosine angle between them. Let me show what I mean by that. Let's say we have a vector A and we have another vector B multiplying themselves. So scalar products simply mean that the magnitude of the two vectors and the cosine angle between them. So the product of the magnitude of these two vectors is just simply A and B multiplied by the cosine angle between the two vectors, that is A and B. So that's just simply everything for the definition. So we have some properties of vector multiplication dot products, which we'll be looking at right now. Alright, so for our first property, we have that it is commutative. What do I mean by that? I simply mean that, let's say we have vector A multiplied by vector B. So we can also write this as B multiplied by vector A. Is commutative. It doesn't really matter where you put the first or the second. It's commutative. And another property that we have again is that when two vectors are parallel, the angle between them is 90 degrees. So what I simply mean by that, we all know what parallel angle are. Let's say we have our base here, and this is at 90 degrees, right? So this is parallel to this here. So if two vectors are parallel at an angle, it's just simply, that is the cos angle, and we all know that cos 90 is equal to 0. So because the angle is parallel and there's no work done in parallel angles, so it's just simply 0. So let's say, for instance, we have two vectors A multiplying vector B, right? So let's say, like I said earlier, the magnitude times the cosine angle between them, this is 90 degrees. So therefore cos 90 is equal to 0, and 0 multiplied by AB is equal to 0. So if the dot product of two vectors are 0, they are perpendicular. So if we are asked to find anything, and therefore we have our answer 0, so it simply means that our angle here is perpendicular. Well, similarly, our unit vector are mutually perpendicular. So let's say we have our unit vector x, and we have another unit vector y, I have another unit vector z. So they are mutually perpendicular, meaning that vector x multiplied by vector y is same thing, is equal to vector y multiplied by vector z, and the same thing as that's a vector, sorry, unit vector x multiplied by unit vector z. they're all equal to 0 because they're mutually perpendicular. Well, when two vectors are parallel, the angle between them is either 0 or 180. From our simple maths, we know that parallel angles are just angles in straight line that they never meet. So therefore, there's no angle between them. So meaning the angle is either 0 or 180. So if we have two vectors, A, okay, two vectors A and B, that is from our definition earlier, we have the product of the magnitude and the cosine angle between them. And we'll have our first cosine angle as 0, and we all know that cos 0 is equal to 1. So our answer here is just simply the product of the two magnitude. How about we have the cosine angle as 180? That is cos the magnitude AB times cos 180. We should have negative AB. So we should know that it's only the sign that changes between 0 and 180. On that point, I would like to make here is that the square of a vector is the square of its magnitude. So let's say we have two vectors, two similar vectors, A, and we have one same vector again, A. So if we were to multiply these two vectors, that is from what we did here, we should have A cos 0. So now why do we have cos 0 here? We have cos 0 because these are two same vectors, and for the fact that they are same thing, they are at angle 0 to each other. So it's simply a. That's if you are multiplying two same vectors. And A times A is equal to A squared. Alright, so let's try out a problem here. Let's say we have if vector A is equal to this plus AZ A, and we have our vector B as this. So applying what we've learned from what I said previously. So vector A multiplied by vector B. So this multiplying this, from my previous video, I said I made it clear that this will multiply this would multiply this will multiply this, because they are of both similar components. So we combine similar, we do the arithmetic component by component. So from what I said earlier from my definition, I said that scalar product is defined as a product of magnitude of the two vectors and the cosine angle between them. So therefore we're adding only the magnitude. So AX, or should I say we're multiplying only the magnitude. AX bx, right? Only the magnitude, ignoring the unit vector because they are mutually perpendicular, plus ay by plus az bz. So that is all for this.